Here in this demo, you can see real-time pose estimation on NVIDIA Jetson Nano, pre-trained models for human pose estimation capable of running in real time on Jetson Nano.
Hello everyone, welcome to Make to Explore channel. First of all, thank you to all our subscribers, viewers, and supporters. In this video, let's see a new computer vision, machine learning and artificial intelligence-based project. Real-time body pose estimation on NVIDIA Jetson Nano development board. Jetson Nano is a small developer kit, powerful single-board computer that lets you run multiple neural networks in parallel for applications like image classification, object detection, segmentation, and speech processing. So, without any delays, let's get started and see what does actually mean by body pose estimation.
Human pose estimation, or articulated body pose estimation, is a computer vision-based technology that detects and analyzes human posture. It is an important problem in the field of computer vision. Imagine being able to track a person's every small movement and do a biomechanical analysis in real time. The technology will have huge implications. Applications may include video surveillance, assisted living, advanced driver assistance systems, ADAS, and sport analysis, etc. The main component of human pose estimation is the modeling of the human body. There are three of the most used types of human body models: skeleton-based model, contour-based model, and volume-based model. Skeleton-based model consists of a set of joints, key points, like ankles, knees, shoulders, elbows, wrists, and limb orientations comprising the skeletal structure of a human body. This model is used both in 2D and 3D human pose estimation techniques because of its flexibility. Then, contour-based model consists of the contour and rough width of the body, torso, and limbs, where body parts are presented with boundaries and rectangles of a person's silhouette. Next is volume-based model, which consists of 3D human body shapes and poses, represented by volume-based models with geometric meshes and shapes, normally captured with 3D scans. Now, let us see what hardware we are going to use in this project. Here, we have used NVIDIA Jetson Nano development board, which is very popular SOM, system on module, or, you can say, single board computer. A powerful developer kit for getting started with AI and machine learning. This NVIDIA development board is capable of deploying computer vision and deep learning applications such as image recognition, classification, object detection, localization, and segmentation. This board is connected with Logitech C270 webcam, which will give a live streaming video feed to Jetson Nano. Jetson Nano will be running Ubuntu OS with Jetpack SDK. We will also use Docker container. So, for this board, Jetson Nano, we have used Network Interface Controller Module, AC8265, which features dual-mode Wi-Fi and Bluetooth. Hence, we can connect it to our router wirelessly and can access the internet on Nano. We will be connecting to same Wi-Fi network using our laptop. So, to control the Jetson Nano through SSH, you must have to connect it to the same local network through Ethernet or Wi-Fi. We will then access Jupyter Notebook to get started with Python programming on it. So, this was all about hardware setup and configuration for this project. Now, let's see all these steps in detail and prepare Jetson Nano to estimate body poses. Let's move forward and see how to prepare Jetson for initial setup. In display or headless mode of configuration, Jetson Nano Developer Kit uses a micro SD card as a boot device and for main storage. It's important to have a card that's fast and large enough for your projects. To flash the SDK image we need high-speed UHS 1 or 2 standard SD card. It is recommended that you should use 64 gigs of card, but for the time being, you can use 32 GB also. So, We have to flash this SD card with operating system's image file, which is going to run on Jetson Nano. NVIDIA Jetpack is a comprehensive SDK software development kit for Jetson for both developing and deploying AI and computer vision applications. To download this, we have to go to NVIDIA's website. Here on this link, you can see here they have given instructions for preparing micro SD card for different platforms like Windows, Mac OS and Linux also. So let's check them out. But before that, read note given here. To prepare your micro SD card, you'll need a computer with internet connection and the ability to read and write the SD cards. There are different types of SD card adapters, like these shown here. You can connect them to your computer as per interface available. Again, go to NVIDIA's setup guide. Here, step 1. Download the Jetson Nano Developer Kit SD card image from this link and note where it was saved on the computer. You can download latest version of OS with Jetpack on this link. For different variants of Jetson Nano, 2 GB or 4 GB. Here the buttons given. Click on that. Download will pop up. Save it. It will be a big file, must be in GBs. Then next, format the micro SD card using SD memory card formatter from the SD Association. After that, use your software to write the Jetson Nano Developer Kit SD card image to your micro SD card. Once you flash the OS image into SD card and inserted that into card slot, now it's time to turning on the Jetson Nano and do initial boot setup, means first time startup configurations like language setting, clock setting, username and password setting, etc. So, there are two different types of hardware setups to perform these initial configurations. 1. With display monitor and 2. Without display monitor, which is also called as headless mode. In earlier versions of Jetpack OS, there was only way monitor display was mandatory. But after release of Jetpack version 4.2.1, the second method, means headless method feature included in Jetpack. So, even though you do not have display monitor, you can do initial setup through serial terminal console by just connecting Jetson Nano to your laptop using USB cable. Let's see these both methods connections diagrams in detail. Okay, let's see how to get started with Jetson Nano using display method. How will you connect Jetson to Wi-Fi? Here is the hardware setup for display method. As shown in figure, you can see Jetson Nano connected with monitor using HDMI cable. Then, like other general purpose computer, we can connect keyboard and mouse. We will power Jetson Dev Kit with this 5 volts 4 amperes DC power supply to J25 power jack. Jetson Nano can be powered by a DC power supply with barrel jack connector or with micro USB cable. Let me show you. Here in this picture, you can see different interfaces available on Nano. You can see here these two inputs. At number 3, it is a micro USB port to power Jetson with 5 volts 2 ampere power supply or as serial device input. And then, this number 8 is a DC barrel jack for 5 volts input. Okay, then next, we will also connect our camera. C270 Logitech's webcam. Connect recommended power supply and then turn on the Jetson Nano. As we have mentioned earlier, follow graphical user interface shown at startup, set up and perform all first-time configurations like language, time, Wi-Fi, username and password settings, etc. We have interfaced Jetson Nano with Wi-Fi network interface card AC8265. This one. Therefore, we can connect Jetson to our router wirelessly and can access the internet. So, once you set up Jetson with Wi-Fi, you can execute ifconfig command in terminal to get your IP address of Nano. This is one-time setup only, means once you got your IP, then next time there is no need to connect these monitor, keyboard, and mouse. Instead, you can wirelessly log into your Jetson Nano using its IP address from your laptop. So, this was standard method of setting up Jetson Nano by using display monitor. But suppose you don't have display monitor. Then, how can you set up Jetson Nano for first time? No worries. There is another method called headless mode of operation where you do initial setup of Jetson Nano without display. In earlier versions of Jetpack this feature was not available. But with the release of Jetpack 4.2.1, it is possible. Let's see it in next slide. Okay then, in headless mode of operation, you have to assemble the hardware as shown in figure. In this setup, Jetson Nano is powered J25 power jack. Since we require the micro USB port to access the console for initial setup. Here, first connect this J48 jumper. This will enable this J28 micro USB connector as in serial device mode. This is headless method, so there will be no monitor display. We should connect Jetson to our laptop by using USB serial method to access using serial port. We will power Jetson Nano with this 5 volts 4 ampere DC power supply to this J25 barrel jack. Once you connect your setup like this, then turn on the Jetson Nano. It will be detected as COM port in your laptop's device manager. Then, do serial SSH into that port. You will log in there into root. Then you have to list the existing Wi-Fi networks. On YouTube, you will get plenty of video tutorials showing how to connect Wi-Fi network through terminal or CLI, command line interface. Once you connect to home Wi-Fi network on the same network where your laptop's Wi-Fi is connected, find out the IP address assigned to Jetson Nano by your router. You just need to give ifconfig command in terminal. Once you get your IP, then you will not need to connect this USB serial cable again on next boot. Jetson Nano will automatically connect your home network wirelessly. And you can access it through your laptop wirelessly. So, this was headless mode of configuration. We have spent some extra time here for explaining this method since it is very important for this project. As we are going to use Docker container and we will use Jupyter Lab server for wirelessly interacting with Jetson Nano from our laptop or PC. So let's move forward and see more info about what is Docker container. Okay, in this session, we will see about NVIDIA Machine Learning Docker container. But before moving forward, let's first see what is container. A container is an executable unit of software where an application and its runtime dependencies can all be packaged together into one entity. Since everything needed by the application is packaged with the application itself, containers provide a degree of isolation from the host and make it easy to deploy and install the application without having to worry about the host environment and application dependencies. It is kind of virtualization technology that makes easy for us to develop and deploy apps inside the neatly packaged virtual containerized environments. So, you can see here comparison between virtual machine and containers. Containers are more lightweight than virtual machines. Now, let's see what is Docker. Docker is an open source platform for creating, deploying, and running containers. Docker is included in Jetpack, so running containers on Jetson is easy and does not require any installation. You just need to pull particular Docker image you want, like NVIDIA Machine Learning Docker Container, DeepStream, etc. A Docker container is a mechanism for bundling a Linux application with all of its libraries, data files, and environment variables so that the execution environment is always the same on whatever Linux system it runs and between instances on the same host. Unlike a virtual machines, which has its own isolated kernel, containers use the host system kernel. Therefore, all kernel calls from the container are handled by the host system kernel. A Docker container is composed of layers. The layers are combined to create the container. You can think of layers as intermediate images that add some capability to the overall container. If you make a change to a layer through a Docker file, then Docker rebuilds that layer and all subsequent layers, but not the layers that are not affected by the build. This reduces the time to create containers and also allows you to keep them modular. Docker is also very good about keeping one copy of the layers on a system. This saves space and also greatly reduces the possibility of version skew so that layers that should be the same are not duplicated. A Docker container is the running instance of a Docker image. You can find more information on this NVIDIA documentation page. Like, why to use a container, what inside it, how to use them, etc. We will share this link in description. Let's move forward and see what is NGC. Basically, NGC stands for NVIDIA GPU Cloud. NVIDIA NGC is a hub for GPU-optimized deep learning, machine learning, and high-performance computing, means HPC software. NGC hosts containers for the top AI and data science software, all tuned, tested, and optimized by NVIDIA. Containers on NGC provide powerful and easy-to-deploy software proven to deliver fast results, allowing users to build solutions from a tested framework. Here on this link, you will find information about how to getting started with NGC, with containers and models on NGC, catalog of various optimized containers for different GPUs. Please go through it for more details. All the links will be shared in description. Moving forward, let us see how to pull and run Docker container from NGC catalog. Here we have used NVIDIA DLI Nano Docker container. Let me show you on catalog. Here you have to search your GPU's name. Like Jetson Nano or Jetson Xavier. Here you can see they have pose demo for Jetson family also. But this demo can be run on AGX Xavier or Xavier NX only. Not for Jetson Nano. So, we can pull base machine learning container, this one. Or L4TML this one. Or this Deep Learning Institute course demo which we have used at the time of recording this video. And then prepare it for pose estimation for Jetson Nano Developer Kit. So, for example, you can see here in this DLI getting started with AI on Jetson Nano container. They have given prerequisites as micro SD card, USB camera such as Logitech C270 webcam or CSI camera, internet connection for Jetson Nano to download this Docker image, and all the other stuff which we have seen earlier. Next, let's see how to use the container. First you have to set the data directory. The data collected during the project is stored in a mounted directory on the host device. This way, the data and trained models aren't lost when the container shuts down. This command below assume the mounted directory is NV DLI data. So make sure you create it first. Then go to the top. Here. This is the pull command which you have to execute on terminal, which pulls this Docker container from NVIDIA's GPU cloud. For that you need to have internet data, because it is of 1.39 GBs file. As they shown here. Hence, when you execute this command, Docker will get downloaded to your Nano. And it will take some time, as per your internet speed. Then, to run the container you have to use container tag that corresponds to the version of Jetpack L4T that you have installed on your Jetson. Like 4.4 or 4.5 etc. The Docker run command will automatically pull the container if it is not on your system already. So, use this command if you have connected USB camera. And this one for CSI camera like Raspberry Pi camera, etc. Important note here that if you have both CSI and USB cameras plugged in or multiple USB cameras, add device number according to that. You can also check with ls-device command. Please do not use the CSI camera through V4L2 interface. So, here they have given meanings of different flags. Use according to your system. Next. When the container is launched, the Jupyter Lab server will automatically be started. Text similar to the following will be printed out to the user. You can connect to it by navigating your browser to http://localhost:8888 or You have to substitute the IP address of your Jetson device if you wish to connect from a remote host. That is all with the Jetson in headless mode. Note that the default password used to log in to Jupyter Lab is DLI Nano. We also tried other container. Let me show you. This one. NVIDIA L4TML. Which contains all these OpenCV packages with support of Python 3. Also, they have mentioned here that it is supported by Jetson Nano. But we were unable to launch the cameras in that Docker container. It was throwing error whenever camera device invoked. We will try to resolve that error and use this container in next project, which will be hand pose estimation and classification on Jetson Nano. Now, let's see the demo. Let's first prepare SD card for Jetson Nano. Here is File Explorer in Windows. You can see here, we have connected 32 GB of micro SD card drive, which we have to format first. Do not use Windows default formatter. Use this SD Associations SD formatter. Please note here to select correct drive, otherwise if you format wrong drive then data will get permanently lost. Once drive is formatted, then let's write the Jetpack image. Means the operating system image on this SD card. So, for that we will use Eacher software. Open Eacher software. Like this. Then select here which image file or compressed image file you want to write to SD card. Then again, select correct drive. Make sure you have selected the micro SD card. Then press Flash button. Flashing process will get started, it will take some time. Wait until process finishes successfully. Once completed, safely remove the SD card. Now let's insert micro SD card into Jetson Nano. So, you can see here, this is the card which we are going to insert into Nano. Here is the slot to insert the card. You will notice that there is latch locking type mechanism to insert the card. Push the card gently. It will get latched. Let's turn on the Jetson Dev Kit. Here, we will see display method first. We have connected display monitor, keyboard and mouse. In display method, during first time boot setup, you have to go, as per instruction given in GUI, configure all with default settings. Then, select your Wi-Fi with proper credentials. Once you get Ubuntu welcome screen, go to top right corner and make sure that you have connected to Wi-Fi correctly. If you have connected to your Wi-Fi, then go to terminal and run ifconfig command. You will get IP address of your Nano, as in WLAN. Since we are connected wirelessly using Wi-Fi. So, this is the IP which is assigned by our router to Nano. Our Nano's IP address is 192.168.0.104, yours may be different. Now, you can SSH login into Jetson Nano with this IP address through your laptop or PC. But your laptop or computer must be connected to same Wi-Fi network. So, this was all about How to carry out initial setup of Jetson Nano using display method. Now, let's see headless method. We have connected USB connection between Nano and our laptop according the diagram given. Then you have to go to your device manager in Windows PC. Here, you will notice that Jetson Nano will get listed as COM device. You can use serial communication software like PuTTY and select proper COM port and log into Nano. After you connect using PuTTY, you will see same steps which appears during graphical setup, but instead of GUI, it will be prompted from console. There you will be prompted to select language, keyboard type, region, username, password, time zone, and then Wi-Fi to connect with. But you can skip Wi-Fi setup if you want and later use Network Manager, NMCLI method, a command line tool for controlling Network Manager. As per your convenience. Sometimes device will restart after setup is completed. Don't worry. Just log in with the serial method. Once you successfully logged in and connected to Wi-Fi, run ifconfig command. You will get IP address of your Nano, as in WLAN. Since we are connected wirelessly using Wi-Fi. So this is the IP, which is assigned by your router to Nano. Our Nano's IP address is 192.168.0.104, yours may be different. Now, you can SSH login into Jetson Nano with this IP address using your laptop or PC. But your laptop or computer must be connected to same Wi-Fi network. Here, let's start new PuTTY session using the IP address we just copied. Select connection type as SSH instead of serial. Paste the IP address of our Nano in this field of IP or hostname. And then, click on Open. First time it will show some warning about SSH key. Just click Yes here. Then log in with username and password which you have entered during setup. If all got set up well, you will get one more console prompt here. Now you can close the other connection session. As well as interface also. Which is the serial one. So, when Nano boots on next time, it will automatically connect to Wi-Fi. We won't need serial connection anymore. Here, it is recommended that you should update and upgrade Jetson OS before going to further setups. Now, let's see how to download and install the Docker container from NVIDIA GPU Cloud. For that, go to this link. All these important links will be shared on our GitHub, as well as in the description of this video. Here, we will go to the NGC catalog of containers. In this filter, we have to search for name of our GPU, like Jetson Nano, Xavier, etc. All containers related to this query will get listed down there. We have used this DLI Nano course container. So, back here, you can see different other containers like L4T Machine Learning, Base L4T, etc. But first, let's see more info about this DLI getting started with AI on Jetson Nano container. It is originally built for this deep learning course. Here is the pull command showing link to download the container. You can copy it by clicking here. You should put correct Jetpack version of your system currently running. So, At the time of recording and experiment, we have used Jetpack 4.5 US English version. Just note that. Then go to terminal again and paste the pull command. Then click enter. This command requires super user credentials. Therefore we need to use sudo. Manifest unknown error will occurs when you enter wrong Jetpack version, different than you are currently running on your Nano dev kit. So, just make sure that you entered correct Jetpack version. If everything entered correctly, container will starts downloading. It will take some time. Since these image files are usually larger, in gigabytes, download time depends on your internet speed. Okay, now, download got completed. It took approximately 10 minutes in our system. It is of 1.39 GB file. Let's move forward and see how to use the container. Here, the step 1. Set the data directory. The data collected during the course is stored in a mounted directory on the host device. This way, the data and trained models aren't lost when the container shuts down. Let's create directory for data. Name it as NVIDIA-data. Then step 2. Run the container. So here they have given commands for both type of cameras. USB camera and CSI camera. Choose as per your hardware. We have used Logitech C270 camera. So we will run this USB camera command. Click enter to run the command. You will see this message saying, allow 10 seconds for Jupyter Lab to start. It will show link and password to access the Jupyter Lab server. Let's copy this address and note down the password. Then, go to your internet browser. Paste and go to that link. You will be asked to enter password to access the Jupyter Lab. Enter password and login. That's it. You can see here Jupyter Labs launcher. Here with all the options like terminal, Python consoles, etc. So, in this way, we have seen how to set up Jetson Nano to run headless. Download or pull the Docker container from NVIDIA's GPU cloud. Then, we have also seen how to run Docker container and access the Jupyter Notebook into that. Once above all the setup get done, our next remaining task is program Jetson Nano to estimate body pose. For that we will use Python programming with different OpenCV and machine learning libraries. Let's see that in next session. Go to this GitHub link, where they have given detailed stepwise procedure to detect human pose, which include all the required prerequisites and getting started documentation. So, what this TRT pose project will cover. It aimed at enabling real-time pose estimation on NVIDIA Jetson. You may find it useful for other NVIDIA platforms as well. Currently the project includes pre-trained models for human pose estimation capable of running in real time on Jetson Nano. This makes it easy to detect features like left eye, left elbow, right ankle, etc. Training scripts to train on any keypoint task data in MS COCO format. This means you can experiment with training TRT pose for keypoint detection tasks other than human pose. So, to getting started with this project, we have to go through these all steps. Step 1. Install dependencies. Install PyTorch and Torch Vision. To do this on NVIDIA Jetson, it is recommended that to follow this guide given on this link. Do all the steps and then move forward to install Torch 2 TRT module by following these steps. Then next, install other miscellaneous packages like these. In step 2, install TRT pose. Once you cloned and installed TRT pose module, then in step 3, run the example notebook. Means it will get listed in data folder. Let me show you on Jupyter Notebook. Here like this. These all folders. So here on documentation. They have given 2 human pose estimation models, pre-trained on the MS COCO dataset. You have to download them. Here, throughput and FPS is shown for each platform. Like Jetson Nano and Jetson Xavier. Xavier is more powerful than Nano, so it has higher throughput FPS. So, to run the live Jupiter Notebook demo on real-time camera input, download the model weights using the links given here. Place the downloaded weights in the tasks/human_pose directory. Let's see. Go to JupyterLab Notebook again. Then go to Files. Then Tasks. Then Human Pose. Here these are. We have downloaded and placed them earlier. Okay. Now let's see how to get the required dependencies, prerequisites, and mandatory Python or OpenCV packages for this JupyterLab environment. All these steps. Commands. You have to run on terminal in JupyterLab. Let me show you. Go to JupyterLab. Here, open the terminal. Like this. Then on this console, you have to run all the steps. Means, in short. You have to clone the source code repository, install the required OpenCV or Python packages. Like NumPy, PyTorch, TorchVision, Cython, scikit-learn, matplotlib, etc. From this terminal. We will not cover these steps, since it is time-consuming process. Some packages like scikit-learn takes very long to get install. So you have to do these steps on your own. Using Python package managers like pip. But, if you face any issues during this project, feel free to ping us on Telegram, or you can also send us email at info@make2explore.com. We would be happy to help. Now, let's see our main code. Go to Tasks. Then in Human Pose directory. Here, open this live demo notebook. This is our main code of body pose estimation. Code is self-explanatory and well commented. Each step details are given. If you want to run any cell, you have to input Shift-Enter keys. Or, you can click here also to run the selected cell. Before running this notebook, it is mandatory to download and install all the dependencies and prerequisites, which are given in documentation. Otherwise you may face errors. To avoid camera errors, connect camera before launching container. Here in this deep learning course container, there are notebooks to test your cameras. Let me show you. Go to Home screen. Here in File Explorer, you will see this Hello Camera folder. In that folder, you will see these 2 notebooks for USB camera and CSI camera. Using those, you can test your cameras before going to pose estimation experiment. Check that have you getting live camera feed or not. Now, let's see final demo of the project. Here in this demo, you can see real-time pose estimation on NVIDIA Jetson Nano. Pre-trained models for human pose estimation capable of running in real time on Jetson Nano. This makes it easy to detect features like left eye, left elbow, right ankle, right elbow, etc. So, in this way, we have completed this project. If you face any difficulty in replicating this DIY project, feel free to ping us on Telegram, or you can also send us email at info@make2explore.com. We would be happy to help. Thank you.